Welcome to this explainer. Today, we're diving into something that feels like science fiction but is happening right now, the massive leap to 6G technology. We're going to break this down into the problem, the paradigm, and the practice. Now, if you're sitting there thinking, wait, didn't 5G literally just get here? Well, you are definitely not alone. But the reality is, as we push the absolute limits of what our machines and networks need to do, we're finding out that 5G actually isn't quite fast or smart enough for what's coming next. So let's explore the exact problems forcing this technological leap, the incredible structural shift required to solve them, and how it's going to completely revolutionize our world.
Right, let's tackle the elephant in the room. Why do we need 6G already? It's a completely fair question. We were all promised that 5G was going to be the ultimate silver bullet for everything, from smart cities to self-driving cars. But when we actually try to run cutting-edge, real-time autonomous systems, we are starting to see some pretty major bottlenecks. The truth is, while 5G is fantastic for downloading a movie to your phone in seconds, it really struggles under the intense, crushing demands of latency-critical artificial intelligence. To really get why this is happening, we need to look at the hard numbers. Recent empirical tests over in Central Europe revealed a really surprising limitation. When testing real-world 5G networks, researchers found that the latency, the delay in data transfer, is hovering between 61 and 110 milliseconds. Now, to you or me clicking a link on a website, 100 milliseconds feels basically instantaneous. But to an AI making split-second life-or-death decisions, that delay is an absolute eternity. So, here's the crucial issue. 5G falls drastically short of the strict sub-20 millisecond latency that advanced applications absolutely require. Think about it. If you're wearing an augmented reality headset, any delay over 20 milliseconds creates a lag between your actual head movement and what you see on the display, which is a one-way ticket to severe motion sickness. Or imagine a fast-moving robotic arm in a busy factory. A 60 to 110 millisecond delay means that robot might accidentally strike a human worker who just stepped into its path before the system even registers that they're there. We literally have to drive this latency down. A big chunk of this delay comes down to how data physically travels right now. In some recent tests tracking data between two geographically close points in Austria, researchers watched data take these wildly inefficient cross-border detours. We're talking over 2,500 kilometers, bouncing from Vienna up to Prague, over to Bucharest, and all the way back, just to serve local requests. It completely wrecks response times. Our current setup relies way too much on distant core networks instead of processing the data right there on the edge where it's actually being generated. So, to fix this, we are looking at the 6G paradigm shift. This means moving away from just basic connectivity and toward fully distributed intelligence. The official 6G targets, which are known as IMT 2030, are frankly staggering. We're talking about crushing latency down to mere microseconds, specifically 0.1 to 1 millisecond. We're looking at peak data rates blasting up to 200 gigabits per second and spatial positioning accuracy down to a single centimeter. I mean, these aren't just minor software updates. These are the foundational upgrades required to support massive machine perception. It's what will allow fleets of robots or autonomous cars to instantly share a flawless, real-time map of the world around them. Now, you're probably wondering, how on earth do we hit speeds like that? Well, it's not just about building bigger antennas. We have to get way smarter about our data. 6G is going to heavily utilize something called semantic communication. Basically, the network becomes smart enough to extract and send only the actual meaning of the data, instead of dumping massive raw files across the network. For example, instead of a robot sending a super heavy 4K video live stream of a room just to show where a cardboard box is, the network extracts the semantic meaning, the exact 3D coordinates of that box, and sends only that tiny fraction of data. That is a total game changer for minimizing latency. But pulling off these incredible metrics requires a complete structural overhaul, moving to what we call a multi-plane 6G architecture. This new architecture builds a really holistic framework made of 4 specific layers, or planes. At the very top, the robotic vertical plane manages the physical tasks. Below that, the intelligent service plane acts as the brain of the operation, crunching complex AI. Then you have the data governance plane, which is constantly making sure everything is secure and compliant. And finally, the network service plane handles the actual physical sensing and connectivity. So sensing, AI, data security, and physical movement are dynamically, continuously coordinated across these layers in real time. Let's bring this down to earth and look at how this multi-plane architecture is going to completely revolutionize autonomous robotics. There is a stark evolution happening here.
With 5G, the network basically acts as a fancy wireless tether, just connecting a robot's cameras back to a controller. But with 6G's integrated intelligence, we are fully embedding the sensing and the AI directly into the network itself. So a robot doesn't just have to rely on its own two cameras anymore. It taps into a unified brain and literally every other sensor connected to the network. It creates this massive, shared intelligence for flawless fleet coordination. A perfect real-world example of this network intelligence is the dynamic safety zone. Right now, on factory floors, robots are usually locked inside these heavy, static, physical cages so they don't hurt anyone. It's safe, sure, but it is incredibly inefficient. 6G is going to replace those physical fences with an invisible, AI-calculated virtual bubble surrounding the robot. This bubble instantly adapts. It expands if the robot speeds up or shrinks if it stops, safely preventing any collisions without having to shut down the entire assembly line just because a human walked by. Of course, maintaining that dynamic safety bubble is no joke. The 6G system has to instantaneously fuse data from all those network sensors, run it through the intelligent service plane for processing, and then instruct the robot's physical motors in real time. The entire network is constantly perceiving the room, reasoning about potential crashes, and executing control commands with sub-millisecond reliability. It's an incredible continuous loop. And this goes way beyond the factory floor. This exact same paradigm shift is going to usher in a brilliant new era of intelligent, ubiquitous remote healthcare. To handle the insane influx of real-time medical data securely and without any lag, 6G routes information through a really specific spatial hierarchy. It starts at the very bottom, with what we call do computing. Think of these as intelligent on-body smart wearables that prioritize instant local responses. Like if it detects a dangerous irregular heartbeat, it acts immediately on your body. From there, the data flows up to the edge in local clinics, the fog for broader regional analysis, and finally all the way up to the cloud for global long-term pattern analytics. It ensures the critical, life-saving decisions happen instantly right on your skin, while the heavy number crunching is handled up in the cloud. All of this really culminates in one massive conceptual leap. We are moving away from the Internet of Things, which, let's face it, is mostly just simple connected gadgets, to a deeply interconnected Internet of Everything. We're talking about seamlessly merging people, processes, data, and intelligent machines. This is what unlocks mind-blowing innovations like the Internet of Skills. Imagine a specialized surgeon in New York performing remote telesurgery on a patient in Tokyo, relying on a network that absolutely guarantees less than a 10-millisecond delay and delivers flawless, real-time physical feedback to the surgeon's hands. So, as we wrap up this explainer, we're looking at a future that feels almost like a sci-fi movie, but the foundation is literally being poured right now. It leaves us with a really huge question. How will our daily lives, our ethics, and our society adapt when our communication networks become truly actively intelligent? When the infrastructure all around us doesn't just passively carry our text messages, but actively perceives our world and makes decisions in real time? It's a fascinating, complex challenge, and we're going to be watching it very closely. Thanks so much for joining me for this explainer, and as always, keep questioning the world around you.